So in this video, I'm going to be working through worksheet 3.1, which is a mixture of a lot of different rational expressions. And a rational expression just means an expression that involves fractions. And if you haven't already, you'd want to watch the video for this, where I work through each one of these concepts here. These are all the concepts you need to keep straight when you're dealing with simplifying expressions that are fractions, or in other words, rational expressions. So just run through them real quick. When you're multiplying, you always multiply top by top, bottom by bottom, but that also means that the commutative property of multiplication is in play, which means you can do those in any order you want. You also have to remember not to say no to bad canceling. So part B, it says to cancel, it must be a factor of top and bottom. And C is division is multiplied by the reciprocal. But generally, by division, we just cancel when we recognize that, for example, x plus 2 is on top and x plus 2 is on the bottom. We just divide that by saying it's 1. And then the fourth one is to add and subtract. You have to have a common denominator, otherwise they would not be like terms. And then the fifth one was when dealing with complex fractions, that means a fraction within a fraction. One way to get rid of to simplify it is to multiply top and bottom by the common denominator of all the inner fractions. Okay, so that's just a quick rundown, but there's a video on me talking about each one of those and doing examples. So once we get that idea in our heads, we can hop over here and start doing this. And you notice in the first one, this is like one you've done before when we were talking about exponents. But to simplify this, we really there's only one fraction, so we're just reducing here. So just pay attention to the canceling rule, really. That in order to cancel something, we have to be aware of it has to be a factor of the top and the bottom. So this is really already kind of written in factored form. So let me should I rotate this? Yeah, maybe I'll rotate this. Does that work? Yeah. Okay. So it's already written in factored form, except for the 16. We could write the 16 as 4 times 4 and the 20 as 5 times 4. So then we can really see the factors. So I'm going to go down here and I'm going to just notice the 4s. I'll use a different color real quick. The 4s cancel out. And that leaves me with 4 on the top and 5 on the bottom. And then I have 2 A's on top and 7 A's on the bottom, so that would leave me with a to the 5th. And looks like we have 1 B left over up top, and we have 2 C's left over up on top. And I just realized I'm writing on the wrong thing. I'm going to hop over here and finish this. Okay. The second one is, once again, I can write that in factor form. I'm just looking for factors that are common, right? So since this is 5 times 5, then I know that this up here, or I could take 5 out of that, out of the 120. So 5 will go in there, 24 times? Yeah. And so we can see the 5's cancel out. So I'll draw a line down here, and I'm left with a 24 on top, 5 on the bottom. There's 3 factors of x up here and 1 factor down below, so that if I cancel those, it leaves me with an x squared. And we have 1 y on top and 5 y's on the bottom, so when we cancel that, it leaves with y to the 4th. And again, these are ones we've already done before, so if I do this one real quick, we'd see that we have a negative 4 on top and a 3 on the bottom, a third, a y to the 4th, and a z to the 4th. Okay, now when I get down to here, notice the commutative property of multiplication doesn't help me here because I'm not multiplying. It's 2x plus 6 and 4x minus 12. So if we hop back over to this guy, and reread these things. So to cancel must be a factor of the top and bottom. So that's important to remember. And yeah, that's the main thing we have to remember. So if we hop back over here and we say, look at, is 6 a factor of the top and bottom? Well, the only way we can know that is if we write this in factor form. So the first thing I would do with all of this is factor first. So I would rewrite this as 2 times x plus 3. That would be factored form. And the bottom I'd rewrite as 4 times x minus 3. And so now we can see the factors. And we could break 4 down into further as in 2 times 2. Right? So that's 2 times 2. And then you can see clearly that we're able to cancel those two 2's. So then I'm left with on top x plus 3. On the bottom I'm left with, and I'd probably just multiply the 2 back through because we're trying to write this in simplest form, right? So that'd be 2x minus 6. Okay, we just factored them, not because factoring is simplifying, we factored them so we can see what can cancel and what can't. And then when we're done, we multiply it back together. Okay, so grab this one again. You might be tempted to do that 8 and 20 and do some reason, but they're not factors at the top and bottom. So in order to see the factors, we have to factor first. So we go like this on top, and it looks like there's an x and an x. And I'm looking for factors of 20 that add up to 9. That'd be 5 and 4, right? So I put a 5 there and a 4 there. I could have switched the 5 and 4, it didn't matter. And on the bottom, I'm going to factor out a 2 from that. So I get a 2 times x plus 4. And this time, we notice that, so the factors at the top in this problem are x plus 5 and x plus 4. Not x, 5, x, 4. It's the factors at the top are x plus 5, the whole thing. And there's 2 factors, x plus 5 and x plus 4. So on the bottom, we have 2 factors. We have 2 and x plus 4. So and once again, we can cancel something out here. So we'll cancel that guy with that guy. And what are we left with? Well, and we don't even have to multiply anything back together because it's just going to be x plus 5 over 2. Okay? Now, if you want to take another step, you could write this as 1/2. You could write this as x over 2 plus 5/2. But to me, those are kind of the same thing. There's not one that's more simple than the other. Okay, so if we keep going, here's another one. If I write it in factored form, that would be 6 times x plus 4 on top. And on the bottom, it looks like a x and an x, and probably 3 and 4. Because 3 times 4 is 12, and 3x with 4x is 7x. Yep, works beautifully. And once again, we notice it's a 4x and 4x on top. A 4x on top and a 4x on the bottom. They're both factors. So I can cancel them, and I'm left with a 6 on the bottom. On the top, sorry. And an x plus 3 on the bottom. Okay. And this worksheet, they're not asking you, but we'll just pause for a second. If they were to ask you to make note of any any numbers that cannot replace x with, you'd make a little note over the side here, and you'd say x can't be -3 and it can't be -4, because those are numbers that would make this expression undefined. Okay. Okay, I'm going to stop the video right now and just do the next 6 or so. So you'll be able to see the solutions without necessarily hearing me talk all the time. And that'll speed the video up a little bit. But I would suggest that you pause the video now and do all 6 of them and then come back on and check your answers. Okay, so there is the next 6 problems. I just there's the 7, 8, and 10 and 12, and then we'll scroll over a little bit. Once you see that, go over a little bit to see 9. Actually, maybe I can make this smaller. You can see all of them once. There you go. Now you can see them all at once. So hopefully those are making sense to you. Again, the process is the same every time. We just factor top and bottom so I can see the factors. And I'm looking for factors on top and bottom that are matching, that are exactly the same. And you can see I didn't bother writing the red line through them, but you can see here that I factored the x plus 1s. Here I canceled the x minus 4s. Here I canceled the x minus 4s. Here I canceled the x minus 3s. There are the x minus 2s. And here the x minus 4s. Okay? So, there's some more along here. And I guess I should have done those too. Here, I'll do those real quick. Just a minute. So this is next one's 18, 19, 20. And this video is getting up on time, so I think I'll stop there because the next one we start multiplying, although the multiplication is very similar to what we did before. It just makes because the first step in multiplying fractions is just, in my mind, it just turned into one big fraction because you're just multiplying across top by top and bottom by bottom. And that was that first rule in the simplifying rational expressions list. But I'm going to go ahead and stop this video and upload it and then start a new one for the next problems.